Welcome to this video regarding AEC Interoperability, specifically looking at terrain surface workflows. Our journey begins here in Infoworks, where we have created a file using the model builder. What we want to do is export the Infoworks file to a format which can be used by other AEC applications, such as Civil 3D or Revit. We can do this by going to the Present Share tab and selecting Export to IMX. In the dialog box, we can define an area of the model that we would like to export, or we can simply choose to export the model in its entirety. We can then select what the target coordinate system will be. I'd recommend using the same coordinate system throughout a project as good practice, and to model everything geospatially correct, no matter the application used. This will mitigate against any coordination issues that may arise as the project progresses. As per any file export, we then need to define a destination location and file name. IMX files can be hosted either on a local server and desktop, or in the cloud using either BIM 360 or Autodesk Docs. Once the export is complete, the data is ready to be imported into Civil 3D. It's that simple. Inside of Civil 3D, designers are able to use the Infoworks data by importing the IMX file we created in the previous step. Users can do this by either using the Insert or Infoworks tabs on the Civil 3D ribbon and selecting the Open Model tool. The dialog box is intuitive and begins by requiring the user to define the IMX file they'd like to open. This is then followed by assigning the correct or appropriate coordinate system for the import process. Again, I feel it is good practice to use a consistent coordinate system throughout a project and only deviate from this if absolutely necessary. We can then identify an object settings XML file that we want to use for the import process. This XML file can be fully customizable and is used for assigning Civil 3D object styles and layers to the imported elements. Finally, we have the refined selection set, which allows users to pick exactly which objects or features they'd like to import from the Infoworks model. In this example, we're only interested in the existing terrain surface, the extent of the water features, and specific road alignments, so we shall toggle the options in our selection list as appropriate. Once imported, you can see Civil 3D has created alignments for the roads, polylines for the water elements, and the tin surface for the existing terrain. It's important to note that the terrain surface is only really suitable for preliminary or conceptual design and is in advance of any topographical surveying taking place on the project. It is, however, useful for identifying the general levels in an area of a proposed site and will give designers a general idea of what the terrain is doing in any given location. Back inside of Infoworks, we have the ability to import Civil 3D surface data into the model once further project work has taken place. This could be surface data taken from an updated survey, giving more accurate elevations on a further refined grid, an exported surface from a linear corridor, such as a road, railway or earth embankment, or it could simply be a proposed tin surface created inside of Civil 3D, using points, feature lines, and so on. Civil 3D surfaces are imported by connecting a relevant DWG to Infoworks via the Data Sources panel and then selecting the pertinent surface or surfaces they'd like to import from the list provided. When importing a Civil 3D surface, users need to categorize the terrain surface as a ground surface, place it above the existing elevation in the hierarchy, and ensure it has been toggled on for Infoworks to display the data. Importing Civil 3D data inside of Infoworks is beneficial, as it allows design teams to better present their project proposals to other stakeholders, such as clients, in a more aesthetically pleasing scenario, communicating and adding further project context and understanding. Finally, we're going to look at how to connect a Civil 3D surface to Revit. Note that this workflow can only be done via the cloud and requires a license of either BIM 360 or Autodesk Docs to be performed successfully. Starting in Civil 3D, users need to export the surface data by going to the Output tab and selecting Publish Surfaces from the ribbon. The dialog box will then ask the user to select which surface or surfaces they'd like to export and the destination location and file name. Note that the file name must be suffixed with .shared before the file extension. Inside of Revit, users must first ensure that the project is geospatially correct before performing the import. When this is done, by going to the Insert tab and selecting Link Topography from the ribbon, users can navigate to where the exported Civil 3D surface file is stored in the cloud. When the import is complete, the topographical surface should align to any design work modelled inside of Revit. The material of the surface can be changed via the object styles inside of the Revit model. The surface can now be used inside of various Revit views, including 3D isometric views, sections, elevations and plans. It can also be used as a host for objects to follow using the railing tool. This is the perfect solution when designing fencing that needs to follow a proposed or existing terrain. And that concludes this video on terrain surface workflows. I hope you now have the understanding of how and where you can use surfaces inside your AEC project. Thanks for listening.